Hello everyone and welcome to this GSMA LinkedIn Live. My name's Jo Gilbert and today we're going to be focused on data and AI and the digital transformation of industry in the 5G era. So we're really delighted that you can join us. We're going to move to the first slide so I can introduce our speakers today. So I'm delighted to be joined by some fabulous speakers from across the globe. We will be joined by Mukund Shenoy from the Intel Corporation, Petteri Venica from Cognite, and Mark Chapman and Angela Logothetis from Telstra. And as mentioned, I'm Jo Gilbert and I'm the Digital Industries Lead at the GSMA. So without further ado, let's move on to the agenda. And to put this into context, the industrial companies have been gradually progressing on digital transformation over the last few years, with innovation in cloud, digital twin, IoT and AI driving new opportunities for cost saving, safety management, sustainability, productivity and much more. So that's the context for our agenda today, and we'll be focusing on the AI and data element. So we'll be opening with Mukund from Intel, who will be introducing the industrial edge and private 5G networks, and also really setting the scene and talking about the transition into an industry 4.0 setting. And then following that, Petteri from Cognite is talking Kaizen, not keynote. So really some of their first-hand experiences of extracting meaningful data in an industrial setting. And then finally, for the presentations, we will be moving to Mark and Angela from Telstra, who will be talking to us about the role of the operator and some of their experiences within this sector. And then for the last 20 minutes, we are opening to an audience Q&A. So if you do have any questions as we go through the presentations or later on, please do drop those questions into the comments and we'll pick them up and we will ask them to our speakers in the last 20 minutes or so. Okay, so if we can move to the next slide, please. Just before I move on to our first speaker, I wanted to have the opportunity to introduce to those of you not familiar, the GSMA Digital Industries Forum. It's formerly known as the 5G IoT for Manufacturing Forum. This Digital Industries Forum is focused on connecting the benefits of 5G for the industrial sector. So as the industrial revolution continues towards digitalization and connected intelligence, this community works together to explore all aspects from raw material extraction, refinery, supply chain, component production, assembly and smart warehousing. And we're a community of mobile network operators, enterprises and the broader ecosystem who are working together to meet these 5 pillars. So first of all, understand the needs of the industrial value chain, identify innovation and collaboration opportunities, lift barriers to digital transformation in the sector, share knowledge across partners, and drive new relationships in the wider ecosystem to achieve success. So if that sounds like something that might be relevant to your organisation, please do check us out on the URL there, gsma.com/IoT/manufacturing. Drop us a note and we'd love to hear from you and talk to you about potentially joining our community. Okay, so without further ado, I'm really keen to get on to introducing our speakers today. So if we could move to the next slide and then perhaps the next one along, please. I'm going to hand over to our first speaker, Mukund Shenoy from Intel. Over to you. Thanks so much for joining us today, Mukund, and welcome.
Thank you, Jo. Thanks for having me today on the panel. Appreciate the invite. Hello, everybody. Like Jo mentioned, I work for Intel Corporation. And I'm very excited here to share some of my experiences. I'm in the strategy office of the network and edge group, if you will, focusing on the federal and industrial solutions connectivity strategies. And prior to this role, I've been in Intel's factories for about a couple of decades, working in various capacities in industrial automation, equipment development, process development, etc. And so I've really felt some of the pains and can empathize a lot on some of what factory owners and factory operations managers are going through in terms of the pain points, etc. So while we have a lot of challenges there are also a lot of new technologies that are maturing simultaneously that poised to support and help in addressing some of these challenges. And I'm very excited to talk about some of those challenges and technologies. So if you go to the next slide, and the next one, please. Yeah, what I wanted to share here, essentially, we'll talk a little bit about what are the motivations. What is it that is driving industrials to make a change? What is Industry 4.0, right? I mean, in general, we talk about the industrial revolution, and these are step function changes in the productivity that is being driven in the factories. And so we've seen about 3 of those in the past, and we are in the middle of the 4th one right now. And some of the challenges that factories are facing come from the increasing complexity that we are seeing. One of the things is the type of supply-demand changes that factory owners are seeing. We are seeing constantly a high number of variants in the products that are being manufactured, and to be able to address, to be able to manufacture that on the same line, the companies have to actually optimize some of the manufacturing processes. We got low volumes and high product mix to an extreme of a batch size of 1. So these are some of the supply-demand changes that are impacting the factories. Manufacturing complexity is increasing, and a systemic approach is required to be able to address some of these changes. Digital transformation is what is needed to drive some of these complexities, and this is an example, a case study that we've seen in a leading automotive factory. If you look at the picture on the right hand side, you see this concept of a batch size of 1, right? You can see in the same production line, different types of cars are being manufactured. There are several different use cases that emerge in the factory of the future to be able to address the kind of complexity that we are seeing in current factories. You see sensor networks, car to factory, connected cars, mobile robotics, and supervisory control are some of the use cases that are evolving. There's a lot of research that has gone in terms of how to address this complexity. You see in the center of the slide over there some of the flexibility enablers. You see reconfigurable work cells, flexible routing, smart line balancing. These are some of the capabilities that are driving flexibility that is required to address some of these challenges. So I think in general, what's happening over here essentially is that there's a lot of data that seems to be locked in current factories that needs to be exported out of the machines and the processes. And we've got AI that needs to be, AI models need to be applied to get the most out of these situation. So I think in the next slide, if you will, I talk a little bit about the implications that are going on in terms of the underlying automation systems. Let's talk a little bit about Industry 3.0. The pyramid over here on the left-hand side talks about the current state of the automation systems. You see that there is a hierarchical nature of today's systems. Trapped data in the process and equipment is what is constraining some of the to get the best out of these systems. Hierarchical systems hinder data flow, and slow planning and execution of limits the agility of the system. So there needs to be a fundamental transformation in the industrial automation systems, which we're seeing that happening through at every layer of the automation pyramid. There's a vast number of increase in the number of devices. The IoT revolution, as you know, control functions, that is the PLCs, the manufacturing execution system, etc., are being virtualized, and you see that there is a consolidation of some of these workloads. You see on the right-hand side, the bottom part of the picture shows some of the sensors and actuators that are increasing in number. There is a significant number of these IoT devices that is creating a lot of rich data that comes out of them. On the top of the picture, you see many of the workloads that are consolidated. There is the virtual PLC, the MES, and the ERP systems are getting consolidated at the top over there. So what happens is all of this needs to stay together because of the time-sensitive nature of the data of the use cases in the automation systems. So that's why the connectivity layer becomes very significant. Higher compute and scalability is also something that comes into the system, and massive machine type communications is another feature. So some of these things need to be addressed, and the pyramid is actually now transforming into these pillars, if you will. So there is an ability now to free up the data and apply AI, as well as be able to harness some of the connectivity that is required by the advent of 5G private networks. So let me leave it there, actually, Joe.
Fabulous. Thank you so much, Mukund. That was, great intro to kind of set the scene for us. Thank you very much. Okay, so if we can move to the next slide, please. And I'm delighted to be welcoming Petteri from Cognite, who is going to be talking to us a little bit more about how to turn all that data into meaningful, useful insights and decisions and actions. So Petteri, welcome, over to you.
Hey, thank you very much for my part as well. So thanks for having me, obviously. I'm going to be giving a little bit of a perspective today on the realities in the field. I'll start with the keynote side, and I'll hopefully move into the more pragmatist side at the end of the couple of slides that I'm about to share with you today. We are in the business of Cognite as a company to help our customers obtain, harness, liberate the data, make it into something sensible and useful. And if we move to the next slide, please, I'll start with where, there's a lot of talk about digital twins that's now moving into or fusing into the industrial metaverse. That's the trendier label for digital twin these days, I hear. And we see lots of devices, smart mobile equipment being used, from drones to spot the dog and other robotics and handheld devices, in addition to the existing universe of SCADAs and MESs and PLCs on the field that are there to provide us with data. So collecting data, again, a lot of limelight is stolen by the robotics pieces, although that's not really in a meaningful capacity reality today, as we all know. Then this data comes into context, it's applied somewhere, it is integrated, and of course applied analytics is put on it, and then that turns into insight and automation. And then we all know the halo lenses and so forth that people aspire to wear on their heads. Well, I could argue they probably don't actually in the field, but some technologists like to believe that is aspirational. So if we go from this slide, this is the vision, this is the high level, this is what we always see on keynotes. And if we could take the next slide, please. And then I'll go through a couple of real world examples of where the kind of the halo, the high level, the keynote stuff actually comes to life. So yes, we can today already do autonomous routine inspections in the context of a business process, for example. That is realistically possible today. We have quite a few customers doing that. Next slide, please. We can do first responder use cases with robots. So a robotic mission based on an alarm that is triggered somewhere in the process. So we don't need to send a human into a hazardous area, or we don't need to otherwise cause a bigger storm than is necessary before the first responder robot can go in and actually take real-time streaming footage of it. And then we can reassess it better. So this is again reality today. Next slide, please. PNID walk down, as it's called. So we can already have a robot autonomously navigate a certain walk based on a process, on an actual physical asset. So combining a 3D reality understanding into the robotics and combine that with the process dimension of the actual plant. This is again reality today. So we can do this, but actually, if we then kind of take ourselves a little bit back from these flamboyant, elevated examples, these are not the majority of the day today. And also, if we look at the actual impact potential, yes, these are very illustrious. They work really well in keynotes, but their actual transformative power, if we look at the reality of industrial assets in production today across the globe. This is a nice halo. This is nice icing on the cake, but the cake actually looks quite different. So if we take the next slide, please. In reality, we have this. It's really, really hard. There are humans actually there. I deliberately used robots and all kinds of shiny toys in the previous slides. But the reality of the day is that we have a lot of human workers, subject matter experts in the field, and those are mission critical. Those are the most critical piece of our industrial reality today. And unfortunately, it is really, really hard for the humans to identify and find relevant data. And they're the ones who actually need it the most. So we're in a state where the reality is that data is locked in silos. It needs to be liberated. We can certainly throw a few more robots into the field. That is actually not perhaps the most meaningful way of unblocking the data silos. And again, the possibility is quite well understood, is that when we get to a point where everyone in the field, so all of our SMEs, have meaningful, intuitive, understandable access to the operational environment's data that surrounds them at the moment of their need on their fingertips on any device, not just on the shiniest tablet, but on any device that they happen to engage with, that will be transformative. That is the potential of actual Industry 4.0. I'll get back to that shortly. Next slide, please. Again, today, if we then look at what do people do with the data once they are exposed to it. So, just seeing a signal triggered some way is better than not seeing it, but that's not really where you want to stop, right? So in reality today, because of the complexity of the industrial data landscape and because of the complexity of the tooling, by and large, that people are forced to try and work with to convert that data into something of insight and intelligence and something shareable to others, we're stuck in a purgatory state where we actually need highly skilled consultants or highly skilled IT technicians or professional developers to convert that data into something useful. So and that is driving this big topic of skills shortage, if you will. And a couple of years back, when the AI hype was peaking, people would talk about how they can't find data scientists. Now, I would go on record arguing that it's probably more useful of us to look at how do we simplify the actual working with the data, including applying of AI ML models to it, so that other people can do it, that are not professionally trained in machine learning. It should be about simplifying the complex, not about figuring out how do we hire a few more Stanford graduates from somewhere. So again, the possibility we have with Industry 4.0 is not to keep the complex. It is actually to make it so simple that the existing subject matter experts we have in the field, be they maintenance engineers, be they production engineers, be they process engineers, be they others, that they can actually themselves create more meaningful data-driven solutions for their own use, as well as for the use of their colleagues and teams around them. Next slide, please. And again, the reality today is that a lot of the insight that we have, yes, a lot is stuck in systems like physical source systems, but equally, a lot of it is actually stuck in the heads of people, and they spend an outrageous amount of time doing very, very, very simple routine inspection work that is, not really what they would like to be doing, and it's not the most valuable use of their time either. So these are areas which we can automate, and we should automate, but not to replace the physical field worker from the field. They're actually mission critical for our industrial transformation efforts, but we need to enable them to do better, more intelligent tasks that the robots actually cannot do. Robots are phenomenally good with repetitive, cumbersome, basic tasks, but they're actually not good with creativity. They're far from it. Next slide, please. There was one in between, I think. Yes. So again, today, this is kind of where we are still, again, to just emphasize on the pain and the problem and the possibility we have at hand. Today, because the data is locked in silos, because a lot of work processes are very tedious, it is very slow to react to change, and we are always in a reactive mode. So if we are talking about driving operational efficiencies, driving sustainability agenda, we remain in an extremely and excruciatingly reactive mode. Now, we need to get to a place where that becomes, we're in a real-time environment where the data is provided to the user at their moment of need. So that means we get to a proactive state where people get the data they need without having to go through 10 systems and hooplas to try and obtain it. And once they do obtain it, it tends to be that the data is in a format they can't really use or relate to. So from all of this, there's obviously a lot of frustrations with us showcasing robots, whilst the reality in the field continues to look radically different. So I'll put forward a very, very simple thesis on what Industry 4.0 actually should be about, and where we should all actually start to get to a meaningful impact for the many, many smart subject matter experts we have in the field, who are there to actually enable the real change. And with that, the next slide, please. So I'd argue that instead of looking at the most sexy and keynote sexy robotics use case, of which there are some, but it's not the mass scale. It's not going to lift the seabed on its own. I'd argue that what we should do instead is focus on providing simple access to complex industrial data, and that we should provide that simple access to complex industrial data to the existing tens of thousands, hundreds of thousands, millions, in fact, of subject matter experts we have in the field, and make them more performant, enable them to apply their human creativity on the data that they today cannot access or cannot understand in context. And I think that will be transformative. And yes, we will still have the shiny robots, we'll have the fully autonomous future eventually sometime. But here and now today, to get to 2030 from 2022 today, the biggest potential we have in industrial digital transformation, I would personally argue, is providing the field workers we have today and everyone in offices around those field workers with simple access to complex industrial data in a format they can humanely relate to make that data speak human and make it available for them, and to simplify the complex. Funny enough, that's actually what Google did to the internet once upon a time. And that's kind of the same that Amazon did to e-commerce, is that they just provided simple access to formerly something complicated or inaccessible. And that could be Industry 4.0 in reality. And with that, I'll thank you for the time, for the few minutes, and I'll hand it back to Joe.
Fantastic. Thanks, Petteri. I think that we heard that loud and clear. So silos of data are a big problem, and we need to be moving to that single view, the single view of the factory. I think that makes an awful lot of sense. Thank you very much. We do like the robots as well, though, but of course.
We do. I do as well, and we love them by the light.
But I see getting the foundations right, absolutely critical. Yes. So thank you so much for that. Thank you. And we'll be joining you at the end for the Q&A. So thank you very much. Okay, so then if we can move on to the next slide, please. I am really delighted to be welcoming Angela and Mark. Sorry, Mark. Lost it for a second. Hello. Who are from Telstra in Australia, and will be talking to us about the view from the operator. So thank you so much for joining us. Welcome, and over to you guys.
Thank you so much for having us. Simplified access to complex industrial data. I couldn't agree more. I think the role of a mobile network operator in that context, you kind of think about what are the assets that we can bring to bear on these problems. And the obvious one is mobility. And mobility is actually a fantastic asset, the ability to do anything anywhere. But I think the other thing that most mobile network operators have in most jurisdictions that they operate is a level of trust that isn't necessarily part of all businesses that participate in the data ecosystem. And so as we think about our role in the world that we're talking about here, how to combine that trust, the data, and the capability and access together in a way that's adding transformative value. The first thing that we had to think about ourselves is actually how we think about our go-to-market model, because actually selling someone another X units of CPU or Y units of mobile capacity isn't really the transformative conversation that customers are wanting us to be participating in these days. So the first thing that we have actually done is actually broken ourselves down into a very industry-oriented way of thinking about the world. So you can kind of see 4 pictures on this page. I'll just speak about each of them in turn. So the first one is one of the challenges we have in Australia. We're a very agriculture-rich nation. I think 3 out of every 4 things that are sold overseas with the made in Australia or grown in Australia logo in it aren't. And so actually determining provenance through the supply chain is a really critical thing for our industry. The way that we're participating in this is we've actually built a data exchange that allows authenticated, authorized exchange of data. One of the problems in supply chain is that everyone's really really possessive about their data and no one wants to share it. But in order to get the full end-to-end picture, you have to be able to put those pieces of data together. So we've built a data exchange, leveraging our position of trust to enable the supply chain to be tracked all the way through. We're actually partnering with IBM using their blockchain capacity in this case to provide authenticated management of the provenance of produce. We also can track that every step of the way. And for instance, when a boat's coming in with lobsters and one processing plant is full, we can get that data, tell the boat that they should actually go to a processing plant down the road who'll give them a few more cents per kilo of their livestock to actually move it through the supply chain. So that's sort of one way that we're participating. I won't go through all of these. Another is if you look at the smart video use case that we've got up there for retail. Smart video, I don't think there's anything particularly new about smart video. Smart video use cases have been going around for a while. But the thing that I think is particularly interesting about mobile operators is we've done application marketplaces for quite a while. And the future world is going to have more need for video cameras than really people want cameras all over the place. And so one thing we think about is how can you take a single stream of data and put it through multiple AI models in order to sell different insights to different customers using exactly the same camera. So for instance, a camera sitting over a city intersection, the road traffic authority may be interested in monitoring traffic through that intersection. The police may be interested in collisions in that intersection. Maybe the local council are interested in people walking past that intersection. Same video stream through multiple AI models to deliver insight using the trust and the mobile network assets that we have, in addition to edge compute in that case.
Hey, Mark, and I'd like to touch on the edge compute at the moment because I think it fits in really well with the data conversation that Petri started and then you've been continuing, which is if we think about all of these industries, whether they're manufacturing, agriculture, mining, transportation, they are all today they kind of think about connectivity and cloud as their key technologies. And going forward, they're thinking about data and AI as one of their key technologies as well. And that requires a new level of technology or infrastructure. And it's not collecting all of that data from sensors and legacy systems and legacy devices or even video systems and taking it back up into the cloud, right? They don't want to do that for sovereignty reasons, for security reasons, but also just because of the sheer volume of data. And so fundamentally, they want data out locally to them, whether it's on their premise or in a premise that's very close to them. And they want the ability to be able to process that data in real time, because then it's about, well, it's not just about having the data and processing the data. It's about how do I act on that data? What are the actions I need to take? And quite often that needs to be a real-time type activity. So what they're really looking for is not only the connectivity out near site, but the edge compute or the cloud compute capability out near site on which they can then start to build their data, their insights, and then this automation of their operations through robotics or through quality control or through supply chain that actually leverages that data.
Yes, it's super interesting. Next slide, please. I think that same idea, Angela, we're really seeing also with mining. We do a bit of work with private networks and 5G private networks. In actual fact, we've just recently acquired a company that does underground private networking. As it turns out, a private network without some sort of on-location compute is only marginally useful. So just some thoughts about how the private networking and edge compute comes together.
Yeah, so it's really interesting in the mining sector because sometimes mining is above ground, but as we all know, a large amount of mining happens deep underground. And the mining companies are wanting to automate operations underground, but they're also wanting to improve worker safety underground. And so what they're wanting to do is to collect a vast amount of data from the underground mine. Now that's a huge challenge, right? You can put sensors down there, but then how do you get all of those sensors working together, and then how do you pick up that data and get it above ground to where the processing is going to be done? So as you were talking about, we're actually doing some really innovative things with mining companies to build them underground private networks so that they can start to collect real-time insights about what's happening down underneath the ground, bring that back up, and then use that to automate mining operations, but also use that to make sure that each and every one of their workers is in a safe working environment and accounted for. And as you said, it's the networking and the compute going hand in hand to actually enable this real-time data collection and insights in the mining industry.
Yeah, I love some of the mining industry use cases. They're so cool. So some of the pictures on this screen, the top right one is really underground geospatial digital twins. So it's where you're building a digital twin of the actual topology under the ground. That's actually collected by drones using LiDAR. But when we talk to mining companies, we're really focusing on their three key issues, which are production, safety, and social license. And keeping people away from underground mining equipment is just so critical for safety. And so the ability to map out a 3D environment underground, then monitor people with the appropriate monitors on, and monitor the equipment and its location is a real safety bonus. And all of that is brought to life by underground 5G or 4G and 5G networks with the edge compute doing the processing. Another couple of use cases there are, well, I won't spend terribly long time, but Boston Dynamics is getting a good plug in this show. I think miners in Australia are using for gas detection, so carbon monoxide or hydrogen sulfide underground, literally replacing canaries in the mine with modern robotics. The bottom right one is actually really interesting to me because it's actually one of the first use cases that 5G have brought to life for us. So basically that underground drilling rig, extremely dangerous work. You can imagine you're trying to extend mines and using drills to extend those mines. From time to time, things collapse and people come to harm. With 5G low latency, you finally got the ability through haptic feedback to remotely have that driver using the machinery without actually being in harm's way in the mines. So that's a really great example of 5G underground. And I think the last use case is where I actually sent someone up to the Pilbara, which is a remote part of northwest Australia, just a couple of days ago, to look at how we can use smart video over the top of conveyor belts, because as conveyors take iron ore from the mine site down to some of the shipping sites, they get sprayed with water to stop the dust blowing all the way, but that then cakes on the underside of the conveyor. And using smart video, we can tell when the conveyor is likely to have a breakdown and have a production outage by watching the behavior of the conveyor belt and detecting using AI when the behavior changes such that it needs some unscheduled maintenance. And so that's a really exciting use case.
Yeah, and just for anyone that's not an expert in mining or not Australian, that's actually a giant conveyor belt in yellow that Mark has on the bottom left of the slide. It kind of looks like a giant sky bridge that you may want to walk along, and I can assure you that it's not.
Next slide, please. Do you want to start with government, Angela?
Yeah, so it's really very interesting, especially in the current geopolitical environment, and as a result of some of the lockdowns that happened during the COVID-19 pandemic, that governments have become far more interested in both the sovereignty and the security of their data. Both nationally, but interestingly inside Australia, we're also seeing that at state and at regional level as well, where governments are looking at not only where do I place my data and how I secure my data, but how can I have that data out close to my departments or out close to my population so that I can better serve people. And we're also seeing shifts in government policy around where they want to promote investment and spending, whether it's in central areas or out in regional areas going along with this. And so we're seeing governments really look at data and say, not only what data do I want to collect and who do I want to have access to it, but where shall I place that data and how do I secure that data? And again, we're seeing that drive not only consumption of cloud and data and AI technologies, but it's driving consumption around edge and therefore connectivity, because you're shifting vast amounts of data into places in which they're needed.
Yeah, fantastic. Next slide, please. So I think we've discussed, I guess, how as mobile network operators, we think about bringing mobility, mobile edge compute, and trust as our assets, combined with seeking to better understand our customers' needs to participate in their operational technology transformation. I guess that's how we're going to market. I just wanted to sort of talk about 2 or 3 of the key technologies that we're using, that we've sort of built out and made some investments in. So the first is digital twins. We're working with Microsoft on digital twins platform. Our first usage of digital twins in Telstra has actually been for our tower assets. We've recently done a structural separation and basically sold part of our tower assets. And as you're trying to sell the tower space to third parties, actually being able to visualize is actually really important part of the sales process. But as it turns out, my digital twins expert actually smacks me around the head when I talk about visualization being exciting, because that's not really the exciting part for him at all. The what is a moderately interested question, but what if is a much more interesting question. So we're getting digital twins to the state where we're going to be able to use AI and time series data to be able to simulate what if scenarios. Well, what kind of what if scenarios do you want on a cell tower? Well, we have pretty hot summers in Australia, so it might be a question of, with this air conditioning capability and this electricity load already in the site, how much additional capacity can we add if we want a service level of 99.9% available uptime without having to shed load due to overheating? So those kind of time series what if scenarios, we're actually building out digital twins that can simulate particular events and allow us to run what if scenarios through the network. We're doing that with our cellular network. But we also see this being really useful for our customers. I spoke about the mining geospatial digital twins. I think one of our state governments is building a digital twin actually of their topology to be used for emergency services. So digital twins has been spoken about as a bit of a buzz thing, but we're really starting to see traction on the ground with digital twins. And I think where we'd really like to get to our participation is that lots of companies will do lots of digital twins about lots of things. But a question for me is, how do we actually put the digital twin of, say, our office building, which sits at a particular address, next to the digital twin that's provided by a third party of a digital twin next door? How do we create that ecosystem of interaction and digital twin interaction so that you can actually start modeling out, if you like, virtual versions of the real world? So unlike, I guess, some instantiations of the metaverse that are totally virtualized, the parallel is, how do you create the digital twin version of the real world, and what can you then use that for commercially? I think it's really interesting. And I think thinking about how the distributed fabric of mobility and edge compute can help underpin that fabric of digital data is sort of super interesting to me.
And Mark, I think another interesting thing about what you were talking about, you mentioned right up front of our part of the conversation around how telcos like Telstra are, highly trusted partners. But the other part of it is we're technology partners, and we run a massive amount of our own infrastructure, physical infrastructure like towers, physical infrastructure like fibers, and then we have an incredible amount of energy consumption. And we do lots and lots of things that have parallels to other industries. And a lot of our customers actually come to us and say, well, actually, you manage a lot of data and you manage a lot of infrastructure, and you're leveraging digital twin technology. So you're an ideal sort of partner to come to us and help us on that journey as well. And it's kind of like drinking our own champagne or eating our own dog food for a sort of course of sort of conversation. But the fact that we use this to run our own very, very complex mission critical infrastructure also then gives us the ability to pick up this technology and apply it out to other industries with mission critical infrastructure.
Just so you know, Angela, given the choice of sipping our own champagne or eating our own dog food, I'll take the former any day of the week.
Me too.
Next slide, please. Look, I think we're almost at time. I spoke quite a bit about smart video before. We'll go to the next slide and just talk about one last thing, which is I spoke a little bit about the trusted data exchanges key to optimizing the supply chain. This is something that we're investing in as a telco. It was a bit of an odd investment, I guess, for a telco sort of 3 or 4 years ago when we started to produce this. But what became apparent to us is that telcos do connectivity, but connectivity at the bits and bytes layer is only marginally interesting in 2022. What's interesting in 2022 is connectivity at the semantic and meaning layer. And so we figured that was where we needed to head. And so I've started to build capability in exchanging meaning, whether it's primary producers participating, wholesale and distributors, food retailers. By taking information from all elements of the supply chain, we can actually start to build data chains that become very interesting across a lot of use cases. And I think as telcos, we're uniquely placed to be able to provide this in a trusted infrastructure, in a trusted environment that's accessible from anywhere that you happen to be, and to be able to extract real commercial value and real insight from the data that we're collecting.
Yeah, and just on this, we talked about government a little bit earlier, Mark, but I think government also has a role to play in this, right? In ensuring that there's a sort of national infrastructure that supports the sharing of data across different parts of the supply chain or different parts of the vertical value chain.
Yeah, it's true. It actually reminds me that that we started the conversation on connected supply chain and this capability looking at agriculture products. But what became apparent very quickly is that our mining vertical started talking about, well, there's legislation going in all around the world to prevent modern slavery, and so the provenance of actual minerals is something that people are deeply interested in, and regulations being written. And if you start thinking about, well, provenance of agriculture and provenance of minerals, what's going to be the killer provenance question of the second half of this century? And it's going to be the provenance of carbon in carbon commitments. So if you start down the pathway of being able to build provenance chains and providing certainty around that, the world just opens up in terms of how you can participate in the meaningful management of data.
Yep. Lots of exciting things happening.
Indeed. We might leave it there, Joe.
Fantastic. Thank you so much. That was so insightful. I picked up on a couple of themes. First of all, the mining use case is just I was going to say high priority. What's the word I'm looking for? It's kind of a hot topic at the moment, hot topic mining. And so it's really great to see all of those examples. And then the other theme that I picked up on, which again, Mark, you've just then followed up on at the end, was how we're seeing commonalities across the vertical. So I was initially thinking about the predictive maintenance example that you gave around the conveyor belt, but that provenance element and the provenance between agriculture and minerals, and then linking through to carbon, is that's the first time I've heard that. I think that's I mean, obvious when you say it, but fantastic to be able to pin those two things together.
It's so interesting. We started the industry conversation thinking that we were only going to have conversations that were very specific to the industry. What we actually found is that by having conversations that were at the value level in the organization rather than the connectivity level, and then you have parallel conversations with other industries, a lot of the problems are in common. It's just that you get to the understanding that commonality by having the industry conversation rather than the connectivity conversation.
Yeah, fantastic. And actually, let's bring in and go to the Q&A and bring in Petri, because I think that leads me to my first set of questions. Now, unfortunately, we had Mukund from Intel join us at the start of the session. Unfortunately, he's not been able to stick around for the Q&A, so unfortunately, we'll miss him. But we will, we will hope get lots of great content anyway from Cognite and Telstra. We've had some really good feedback already on the comments. So actually, I think picking up on what we were just talking about, I'd like to kind of roll back right to the beginning with my first opening question, a question for everybody, and that is around the key motivators that are driving this digitalization in the industrial sector. So in your experience, what is it that you're seeing that's motivating? I think we've touched on this, of course, with everything. We've talked about things like safety, but I'd like to hear from you what your focus is in meeting the motivations of the industrial sector. So I don't know, who would like to go first?
Would you like to go, Mark?
Angela,
go for it.
Yeah, maybe I'll just add a different perspective to safety, and it really is around supply side shortages. So across the globe, we're seeing supply side shortages in energy, in labor, in parts, in chipsets, in almost every single industry. There is some sort of supply chain issue. And I think organizations are recognizing that, and recognizing that the problem is just not going to go away unless they start to build in more automation, more efficiency, more just-in-time type supply chain capabilities, more sovereign type supply chains. And so we're seeing a lot of that really driving one, the level of data so that they can understand what's going on, but two, this level of automation and industrialization across a broad spectrum of industries.
Yeah. I mean, at Cognite, majority of our customers are in the energy industry. You could say oil and gas companies in specific, but obviously everyone now refers to themselves as an energy company. There, I would say digitalization is it's about survival. It's about continuing to have a license to produce and operate. So health and safety, environment are utmost priorities. At the same time, there is a colossal need from civil societies towards the energies operators these days to actually be able to produce and adhere to the production commitments whilst doing that in a more sustainable fashion. So it sounds like a little bit of an oxymoron to be able to continue to produce the hydrocarbons and other energies that we actually will need for the coming decades, whilst at the same time do that in a much more sustainable and also like economically sustainable fashion. It's always easy to take a lighthouse site, something that was built 2 years ago and inaugurate this year, and then you talk about how everything is hyper modern and everything is super automated. The reality of the day is that it's actually quite different. We talk about brownfields versus greenfields at Cognite, and the reality in the industrial world is that 99% is brownfield. A lot of it is very, not distressed brownfield in a bad way, but there's severely legacy infused brownfields that have gone through multiple sequences of capital projects to expand their life cycle and expand the assets. So that's a colossal effort that needs to be taken to kind of expand the life cycle of those assets to allow them to continue to operate and produce in a sustainable and economically efficient manner that is also safe for the employees there. So it's a lot that is required, and digital is one tool in that toolkit, but digital has the potential, when applied correctly, to actually elevate everything else around it. So that's the beauty of it. It's instead of looking to find superhuman workers who could do everything magically, which is unlikely going to happen at meaningful scale, we can use digital technologies to actually make the complex task come across as more intuitive and simple for the human workers we do have. Same with the automation side. The automation is not going to replace the humans in a foreseeable time frame. Over time, of course, we're going to see increasing automation, eventually even select fully autonomous assets in operations. But the majority is really about how do we enable the humans we have today to be better? How do we make them into superhumans as opposed to replacing them with automation? And yes, connectivity, edge, cloud, analytics, compute. And again, I love what Mark said. It's about not providing the data. There's an infinite amount of data on this planet. People are drowning in it already. It's not about lifting and shifting into the cloud either. It's about providing context and meaning into the data so that we as humans, or machines and models for that matter, they can understand what they're working with. Just dumping 20 terabytes of time series data into the bin is not going to do anyone good.
And actually, going back to the legacy and brownfield that you mentioned, so I'm guessing that the legacy is part of the reason for this silo problem that we talked about in your session. One of the questions that I was going to actually put to Mukund, so I'll see how see what comes back here. On his slide, he mentioned that the factory of the future is modular. and having interconnection allows a central brain to be able to organize manage the self-organizing processes. And so, my question was around transforming these existing legacy brownfield sites, because very few have the luxury of greenfield. So what do you think is the approach to a brownfield site if you're looking towards a digital transformation? Is it modular? Is it bit by bit? Is it put in the private network?
It has to be bit by bit, like going for the full big bang. It's kind of like in data management. If you go for a full master data management program, and before everything is perfect, no one shall touch anything, you're doomed to fail. Same here, like, break down the elephant into bits. And again, we're quite passionate about landing the common foundation first, ensuring that everyone has intuitive access to complex industrial data in a simple fashion. And then that also serves the second layer and third layer of analytics, dashboarding, automation, application. So everything it's a stack. But I think the one fallacy people fall for often, and too often still today, not that much as 3-4 years ago when the hype was peaking, is that they try to make it into too big of a thing, and they try to solve for everything in one go. It rarely has a great success chance.
And then it does scalability become a problem then? So how do you build to ensure that you move from the proof of concept into a launch, into an expanded solution?
Yeah, that's
I think the flip side of this is I think organizations are looking at what they do to, as much as possible, future-proof themselves, right? So if you select a standardized networking, say 5G, or if you select a standardized edge compute or cloud platform, if you modularize your software components and containerize them, if you have thinner devices and put all of the processing power back on the compute, and if you use things like Mark touched on smart video earlier, but imagine you could censor up everything, and that's going to have inbuilt legacy, or you could stick a camera there and watch everything and just be upgrading the AI in the background to be able to glean more and more data out of what's going on. I think organizations are looking at this and now starting to question, well, yes, I've got this brownfield, and yes, I need to find a way to phase or to move that. But what am I moving it to, and how do I make what I'm moving it to as future-proof, as flexible and as scalable as possible? Because they know that this is the rate of change that they're going to go through is just going to speed up.
Yeah, so, and the keyword of openness and composability, modularity, they're absolutely imperative. So anything you start today, if it's not built on a foundation of openness, interoperability and composability, you're probably bound to fail, because by the time you get to delivery on the first use case batch and onto scaling those onto your other assets, some requirements have already changed. That's the reality today. Something has already changed. So you need to architect everything with extreme flexibility and configurability in mind, which is radically different to how things were done historically, in fact.
I think the other thing is you've got to be prepared to actually start small and throw some of your first stuff away, because if you kind of think about it, if you're doing it piece at a time, the first piece of value you deliver doesn't have the opportunity to synergize against your future, and so its value might be relatively small, and so you've got to build it with relatively small cost. But then you build the next thing and the next thing, and all of a sudden you've got 3 things that you're getting value from and synergy in your data. Actually, your first thing's now encountered a scalability problem. That's okay, rebuild it. So just go shortest path to value and make sure that each bit is economically valuable in its own right, and then be prepared to recode it for scale at some later point in time if that's what you need to do.
And there's also an interesting observation we've seen across our customers when we look at their portfolio of use cases being deployed and scaled. There's always something very eye candy-esque, so, shiny digital twins, which sometimes they have true business utility. Other times they serve more as a beacon of light and aspiration to energize the organization, teams, partnerships, and the ecosystem. That's rightfully valuable in its own right as well. And then at some times, then you ask the actual CFO officer what actually creates monetary value for you from this transformation project, and it comes down to the much more simplistic, mundane looking, production optimization dashboards, reducing poor quality. It's and they don't look that eye candy-esque. There's no robot in them. But if you look at the whole piece for that enterprise, everything has a purpose in it. Everything plays a role. And unless you can energize the departments and the functions and divisions and the leadership and everyone around it, the whole program has a lower chance of survival, right? So it's you need the different pieces to play their own role. It's kind of an orchestra, really.
Yeah, and it needs to link back to those motivations around cost savings, productivity, worker safety, etc. Yeah, absolutely. I'm going to slightly different question. We've got around 4 or 5 minutes left. I'm going to have 2 questions. There's one question that I was just thinking through, a couple of mentions of partnerships. So Mark, I think you mentioned a partnership with Microsoft. I think Intel mentioned a partnership with IBM. What is the role of partnerships in this space? I mean, I guess that we are in a complex situation where there's no single organization that can deliver everything to everybody. So, you know, how do you see the role of partnerships in this area?
Super critical. I think I come from a small industrial town, and one of our industries is an aluminium smelter, and they have potline smelting aluminium. They measure 2 parameters, voltage and current, and stick that through an AI. And by monitoring those 2 parameters, they can tell all sorts of things about the production environment. As a telco, we don't have the first clue. And so the bottom line is that if you think you're going to build that expertise yourself and outsell your expertise to someone who's doing it day in, day out, you're kidding yourself. And so the only way to participate in a meaningful and valuable way is through partnership. And in actual fact, one of the things that telcos can do, because they're actually pretty good with complexity orchestration, is actually bring multiple partners to a solution space in a way that adds value beyond any individual partner by itself. And so partner ecosystem is just fundamental.
Fantastic.
I could not agree more. It is fundamental. So also from a risk management perspective on the buy side, it would be quite foolish if you are aiming for composability and openness and interoperability to put all your eggs in one basket with any, individual provider or vendor. So I think it's absolutely imperative that customers also approach that from a perspective of resilience on their side, risk management, get the best of breed from all the different potential partners that you have around you that offer relevance and value. Obviously, no value, then there's no point. But no one can do it alone. It's you need always to have and I don't know what the magic number on different partners would be for a particular type of a client engagement, but there's always in the mix multiple stakeholders. No one does everything best. If someone comes to you and says we do everything best, walk away or run away.
Top tip. So, okay. Oh, sorry, Angela, were you going to come in?
Yeah, Petri, I was just going to say, I think there are a number of partners that you have, but I also think there's a mindset about building for an ecosystem, and we're all part of an ecosystem. And so whatever I'm building, whether it's connectivity, whether it's compute, whether it's some software, whether it's a device, how am I opening up that to an ecosystem? Because if the ecosystem can't get easy access and consume that in an open way, then this doesn't work. And yes, I may have some big strategic partners, but also I need to think about the broader ecosystem and how they can leverage everything that I do.
Yes,
fantastic.
Absolutely.
Brilliant. Thank you so much. In fact, actually, that's the perfect. I think we should end the Q&A there, because I think that's a perfect summary. It also gives me the opportunity to mention again the GSMA Digital Industries community, which one of our objectives is to bring together that ecosystem to help build partnerships, best practice, learnings and experience. So thank you for that. That wasn't planned, but led me nicely into a lovely plug. And so I think we're going to our last slide now, but before we do that, I want to thank Angela, Mark, Petri, and also Mukund, who joined us for the beginning, to say thank you so much for joining us at your various time zones today. It's been really insightful, and thank you very much for sharing your experiences with us and sharing your time with us as well. So thank you very much. And if we could go to the final slide. So brilliant, thank you. So QR code there. Anybody that would like to find us on our website, please do follow the link, and you'll find lots more content on the website, and also information around how to become a member of our community if you're a manufacturer, an enterprise, or part of the wider ecosystem that's involved in the industrial sector. So again, thank you to everybody, and thanks to everybody that's joined us today on LinkedIn Live. subscribe, and see you next time.